Hello, and just wanted to do a quick little video on the Molebox. So this is actually a really cool cardboard box. Way cooler than any other cardboard box you've ever seen before. Let me prove that to you. So in class, we've been talking a little bit about what a mole is and how it connects to 6.022 times 10 to the 23rd particles. And again, molecules is another word that we can use to represent particles. But we talk about molar mass, we talk about Avogadro's number, but we don't really get to visually think about the connection with volume of a gas. When Avogadro was doing his experiments, he was realizing that if you take different gases and you kept them under the same pressure and temperature, that the amount would be the same. And there was a connection with volume, and that connection is 22.4 liters. And that happens to be exactly what this box is. So, for reference really quickly, let's check this box out. So, this box, as you can see, is pretty hefty. I'm gonna take off my shoe of all things, can kind of show you the reference point. I wear a size 10.5, so I'm not small-footed by any means. So it's a pretty decent sized box, just for reference. And it contains a lot of really valuable information. For example, 1 mole at STP is 6.022 times 10 to the 23rd particles, molecules in this case, which is also equal to 22.4 liters. And some other connections that we can make is that 1 mole is roughly 20% oxygen, and of course the air is mostly nitrogen. I love this side because it's a great reminder of that fact. The Molebox, also because we're dealing with gases, contains information on the gas laws. And those gas laws are, of course, Boyle's, Charles, Gay-Lussac, and the combined gas law, which is 4 of the main 5. Again, we may or may not be talking about gas laws yet, but we might be able to revisit this video when we do for the next unit. Also shares the dimensions of that. 28.2 by 28.2 centimeters or 11.1 by 11.1 inches, which makes sense because my shoes are a little bit more than a foot. It also contains information on STP. Now, probably the most important thing on this box is standard temperature. Again, Celsius is great, but we use Kelvin in science. Again, the conversion is very simple. Take your Celsius, add 273. So if you had 30 here, you would have 303 here. You just add 273. And again, our pressure units that we normally use are kPa or atmospheres for pressure, and millimeters of mercury is a less common, though still used, pressure value. Again, the big two are these. And this is actually the conversion factor. 101.3 kPa is 1 atmosphere. Looking around, the ideal gas law. This is probably the most important one that we have here. PIV-NERT, which is probably the most famous equation of this class, where if you have pressure and volume, that's going to be connected to the amount of moles, the ideal gas constant, which we'll talk about in time, and the temperature, of course, in Kelvin. Again, Celsius doesn't do us a lot of good, even though it's way better than Fahrenheit. So, as you can see, this box has a plethora of different information, which is absolutely fantastic. And again, I'm just really quickly double checking to make sure that we discussed everything on this box, and we have. So again, really kind of a cool thing to talk about. Again, just for another reference, putting it next to a chair, it's a decent sized thing. But this is exactly what 1 mole of a gas would fit in. You know, for there being 6.022 times 10 to the 23rd particles in here, it's maybe not as big as you think. So, this is just a quick video kind of explaining the connection with moles, gases, STP, and of course, showing you the 22.4 liters, which is what this box is. Thank you so much for watching, and again, if you ever need help with that Mole Island stuff, this might be a great visual for you.